Thermodynamics and thermodynamic cycles, a brief overview. Thermodynamics is a branch of physics that deals with the study of energy transfer and its transformation in various physical systems. It provides a framework to understand the behavior of matter and energy, particularly in relation to temperature, pressure, and volume. Key concepts in thermodynamics. Laws of thermodynamics. 1. First law. Law of conservation of energy. Energy cannot be created or destroyed, only converted from one form to another. 2. Second law. Heat naturally flows from a higher temperature region to a lower temperature region, and not the other way around, unless external work is done. 2. It also introduces the concept of entropy, a measure of the randomness or disorder of a system. Thermodynamic processes. These describe how a system changes its state. Common types include isothermal, constant temperature, isobaric, constant pressure, isochoric, constant volume, and adiabatic, no heat exchange, processes. Thermodynamic variables. 1. Pressure, P, force applied per unit area. 2. Volume, V, amount of space occupied by the system. 3. Temperature, T, measure of average kinetic energy of particles. 4. Internal energy, U, sum of microscopic kinetic and potential energies of particles in a system. Thermodynamic cycles. A thermodynamic cycle is a sequence of processes that returns a system to its initial state. It is a fundamental concept in understanding and designing engines, refrigeration systems, and other energy conversion devices. Here are a few common types. Carnot cycle. An idealized reversible cycle involving two isothermal and two adiabatic processes. It represents the maximum efficiency any heat engine can achieve between two temperature reservoirs. Rankine cycle. Used in steam power plants, this cycle involves the vaporization and condensation of a working fluid to generate mechanical work. Otto cycle. The theoretical cycle for most gasoline engines, including four processes: isentropic compression, constant volume heat addition, isentropic expansion, and constant volume heat rejection. Brayton cycle. The theoretical cycle for gas turbines, jet engines and power plants, involving isentropic compression, constant pressure heat addition, isentropic expansion, and constant pressure heat rejection. Refrigeration cycle. Includes processes like compression, condensation, expansion, and evaporation to achieve cooling effects. These cycles are essential in engineering and technology, as they guide the design and optimization of various energy conversion systems to improve efficiency and performance. In conclusion, thermodynamics provides the foundation for understanding energy transformation and the behavior of matter in different conditions. Thermodynamic cycles play a crucial role in various real-world applications by helping us design efficient energy conversion systems and devices.